Hi students, welcome to my channel Sri Academy of Physics and this is Dr. Balaji Rambatla. Students, in this channel I would like to post physics videos of level Inter, B.Sc, B.Tech and M.Sc and some of core branch videos also. Please go through my channel for better understanding of subject in simple way and score maximum marks in academics. In my videos, I provide complete notes of the topic and explain in English and in my regional language Telugu for better understanding of the topic. For this, please subscribe my channel Sri Academy of Physics. స్టూడెంట్స్ ఈ వీడియోలో నేను మీకు చెప్పబోయే టాపిక్ పార్టికల్ ఇన్ వన్ డైమెన్షనల్ బాక్స్. దిస్ ఈజ్ అ వెరీ ఇంపార్టెంట్ క్వశ్చన్ ఇన్ క్వాంటమ్ మెకానిక్స్. ఎంఎస్సి వాళ్ళకి, బిఎస్సి వాళ్ళకి, బీటెక్ వాళ్ళకి క్వాంటమ్ మెకానిక్స్లో ఇది చాలా ఇంపార్టెంట్ క్వశ్చన్ అమ్మా. దీని అప్లికేషన్స్ ఆఫ్ ష్రోడింగర్స్ ఈక్వేషన్ కింద కన్సిడర్ చేస్తాం. ఇక్కడ పార్టికల్ అంటే ఎలక్ట్రాన్ కానీ, ప్రోటాన్ కానీ, న్యూట్రాను. బాక్స్ అంటే ఆటమ్ కానీ, న్యూక్లియస్ కానీ. వన్ డైమెన్షనల్ అంటే మనం కన్సిడర్ చేసిన పార్టికల్ ఎక్స్ డైరెక్షన్లో మాత్రమే మూవ్ అవుతుందని అర్థం. జనరల్లీ ఈ క్వశ్చన్ ఎలా అడుగుతారంటే అబ్టైన్ ద ఐగన్ వాల్యూ అండ్ ఐగన్ ఫంక్షన్ ఆఫ్ ఏ పార్టికల్ ఇన్ ఏ వన్ డైమెన్షనల్ బాక్స్. టాపిక్లోకి వస్తే నేను ఏం చేశాను, ఫస్ట్ ఒక వన్ డైమెన్షనల్ బాక్స్ తీసుకున్నా. దిస్ ఈజ్ ద వన్ డైమెన్షనల్ బాక్స్. ఏ డైరెక్షన్లో ఉందమ్మా? దిస్ ఈజ్ ఎక్స్ డైరెక్షన్, రైట్? This is x direction and its boundaries are this is x is equal to 0 and this is x is equal to a. It means the width of the box is nothing but a. So here box is nothing but either atom or nucleus. The height of the box represents potential energy. Generally potential energy is equal to mgh. Suppose the height is becomes infinity, it means the potential energy becomes infinity. It means the particle is free inside the box and unable to come out from this box. P is a point, P is a particle of mass m which is moving along x direction in a box with velocity v. With a velocity v. This is about this diagram. These walls are rigid walls and there is no chance the particle come out from this box. The particle come out from this box, right? So the particle is bounces at the walls of these two, right? Now, suppose when we solve any problem in quantum mechanics, there are some steps that is called algorithm. First, to solve any problem in quantum mechanics, first write the potential function of the system. First time రాయాలమ్మా, potential function of the system రాయాలి. Potential function of the system. Potential function of the system. ఇది ముందు రాయాలి. ఈ సిస్టంలో పొటెన్షియల్ ఎనర్జీ ఏంటి? సపోజ్ నేను ఎక్స్ లెస్ దాన్ 0 అయింది అనుకోండి. ఎక్స్ లెస్ దాన్ 0, వాట్ ఈస్ ద పొటెన్షియల్ ఎనర్జీ వాల్యూ? ఇన్ఫినిటీ. సో వి ఆఫ్ ఎక్స్ ఈజ్ ఈక్వల్ టు ఇన్ఫినిటీ ఫర్ ఎక్స్ లెస్ దాన్ 0. రెండోది ఏంటమ్మా? వి ఆఫ్ ఎక్స్ ఈజ్ ఈక్వల్ టు ఇన్ఫినిటీ ఫర్ ఎక్స్ గ్రేటర్ దాన్ ఏ. సో ఇక్కడ కూడా ఇదంతా ఏంటి? ద పొటెన్షియల్ ఎనర్జీ వాల్యూ ఈజ్ ఈక్వల్ టు ఇన్ఫినిటీ. హియర్ ఆల్సో ద పొటెన్షియల్ ఎనర్జీ వాల్యూ ఈజ్ infinity. The particle, and here in between x is equal to 0 and x is equal to a, the particle is free. Particle is free means the potential energy value should be equal to 0. So v of x is equal to 0 for this is equal to also 0 less than x less than a. 0 less than x less than a, the particle is free. So this is called the potential function of the system. So first write the potential function of the system. Then you go for second step is write Schrödinger's equation. Schrödinger's equation in each region. In each region. Now, so say this is region 1, region 2 and region 3. So here you have 3 regions. Now let us consider, right? This is x is equal to 0 and this is at x is equal to a. This problem is exactly similar to a string fixed between 2 rigid supports. The string fixed between 2 rigid supports. According to de Broglie theory, a particle moving with particular velocity, it generates its associated wave. So this problem is exactly similar to a string which is fixed between 2 rigid supports and we are plucked at a particular region. Then it will generate the wave. Then it generates the wave, right? It generates the wave. So the wave is exist only in between these 2 points. And here, what is the wave? There is no wave. So the wave function value is equal to 0. Here, there is no wave. The wave is exist only in between x is equal to 0 and x is equal to a. So the Schrödinger's equation is possible only at this region only. So the Schrödinger's equation in region 2 is ఏమవుతుందమ్మా డో స్క్వేర్ psi by డో ఎక్స్ స్క్వేర్ ప్లస్ 2m by h cut square e psi is equal to 0. This is the Schrödinger's equation. So in this region, what is the potential value? Here the potential energy value is equal to 0. That's why the Schrödinger's equation you can represent it as dou square psi by dou x square plus 2m by h cut square e psi is equal to 0. This is the first step and this is the second step. Third one is to solve this differential equation. Now for mathematical simplification, this differential equation you are solved as, say 2m by h cut square e is equal to alpha square. Now this equation can be written as dou square psi by dou x square plus alpha square into psi is equal to 0. Right? Then third step. First one is write the Schrödinger's equation, write the potential function of the system. Second one is write the Schrödinger's equation for the region. Now third step, write the solution. Write the solution of Schrödinger's equation. Write the solution of Schrödinger's equation. Now the solution, this equation is somewhat similar to our simple harmonic motion equation. In case of simple harmonic oscillator, the solution, it may be y is equal to a sin omega t or y is equal to a cos omega t. Similarly, here also the solution you can written as psi of x is equal to a sin alpha x plus b cos alpha x. This is the solution of this differential equation, right? Now, in this equation, a and b are constants. To obtain that values, fourth step, to obtain the values of a and b, apply boundary conditions. Boundary conditions Raiman. Apply boundary conditions. Now, what is meant by boundary conditions? Now, we take two rigid supports. Say this is x is equal to 0 and this is x is equal to a. In between there is a string. The string you are making to pluck at a particular situation, then we are getting the wave, right? Now that wave is appears as like this. It may be, or it like this, or some other. So in all cases, what is this? This point is called node. What is this? This point is called node. When you pluck the string in any ways, at these points, we always have node. Node is nothing but the displacement of the particle should be equal to 0. It means here psi is equal to 0 and here psi is equal to 0. Right? So these are the boundary points. At these boundary points, we have always the displacement of the particle should be equal to 0. It means the wave function value should be equal to 0. Now, the first boundary condition is psi is equal to 0 at x is equal to 0. The second boundary condition is psi is equal to 0 at x is equal to a. Now, apply first boundary condition. Apply first boundary condition. In this equation. Say this is equation number 1. In equation 1. Right. So what is equation 1? Psi of x. What is the value of this? 0. 0 is equal to, what is the x value? What is x? 0. What is x? 0. So this becomes 0 is equal to a sin 0 plus b cos 0. Now from this it is clear that b is equal to 0. Now solution becomes, now the general solution can be written as, దీన్ని ఏ రాయచ్చమ్మా? ఈక్వేషన్లో b value ఏమైపోయింది? This value becomes 0. Now that equation you can represent it as psi of x is equal to a sin alpha x. This is the general solution of the particle in one-dimensional box. Now apply the second boundary condition. in equation 2. Apply the second boundary condition. Second boundary condition in equation 2. We get second boundary condition. What is second boundary condition? Psi is equal to 0 at x is equal to a. So in this equation, what is the psi value? 0. What is x value? A. Now a sin alpha a is equal to 0. Here either a is equal to 0 or sin alpha a is equal to 0. But a not equal to 0, since b is already 0. B is already 0. For example, in this equation, we know that b is equal to 0. Suppose a is equal to also 0. Then what is the value of psi? Psi is equal to 0. It means there is no wave in between these two boundaries. But there is a wave. So, since b is already equal to 0, a not equal to 0. Therefore, sin alpha a is equal to 0. అంటే ఏమవ్వాలమ్మా? alpha a is equal to n pi, where n is equal to 1, 2, 3, so on, principal quantum numbers. Then what is the value of alpha? N pi by a. This is the value of alpha. Right. Now alpha square is equal to, write alpha square ante n square pi square by a square. But at the starting, we consider what is the alpha square value? 2m by h cut square e. Now compare these two equations. But alpha square is equal to ఎంత అనుకున్నామమ్మా? 2m by h cut square into e. రెండు ఈక్యులేట్ చేసేయండి. 2m e by h cut square is equal to n square pi square by a square. And from this, e is equal to formula n square pi square h cut square by 2m a square. This is a formula. But what is the value of h cut? H cut or h stroke? H by 2 pi. When you substitute this value in above equation, En is equal to n square h square by 8m a square. This is the eigenvalue of a particle in a one-dimensional box. And from this equation, it is clear that En value directly proportional to n square, En value directly proportional to 1 by m, En value directly proportional to 1 by a square. So whenever the orbit number is increases, the energy increases. Box width is increases, the energy value is decreases. And particle mass is changes, the energy value changes. If n is equal to 1, what happens? E1 is equal to ఈ ఫార్ములాలో చూడండి. ఈ ఫార్ములాలో n వాల్యూ 1 వేసాను అనుకో, ఎంత వచ్చింది నాకు? h స్క్వేర్ బై 8ma స్క్వేర్. ఎంత వచ్చిందమ్మా? h ఎంత h square by 8ma square. If n is equal to 2, E2 is equal to a. Here what is the value? When n is equal to, this is n square, now it becomes 4. So 4 h square by 8ma square. So this can be written as 4e1. What is e1 value? This is the e1 value. So this is e1, 4e1. If n is equal to 3, if n is equal to 3, what is the e3 value? This is 9e1. So here the energy is e1 is 2, so on. e1 is 2, e2 is 2, e3 is 2, so on, which are in the ratio of 1 is to 4 is to 9 is to 16. It means in particle in one-dimensional box, the energy values are not in continuous, they are appears in discrete manner. First level energy value is 1. Second level is 4e1. Third one is 9e1. Next one is 16e1. So the energies are appears in discrete manner but not in continuous. Now, what is the general equation? So what is the value of alpha? Alpha value is n square pi square by a square. What is the alpha value? N pi by a. Now how to represent this general equation? Now this equation can be written as psi of x a sine alpha. What is the value of alpha? N pi by a into x. This is the general solution of a particle in a one-dimensional box. Here the a is unknown term. What is the value of a? We don't know. What is the value of a? To calculate this a value, apply normalization condition. Apply normalization condition. What is normalization condition? The probability of finding the particle, అంటే దాని అర్థం ఏంటంటే, ఫర్ ఎగ్జాంపుల్ నేను ఇది తీసుకున్న బాక్స్, రైట్, మనం కన్సిడర్ చేసిన పార్టికల్ ఎక్కడుందమ్మా? ఈ మధ్యలోనే ఉంది. ఈ మధ్యలో పార్టికల్ ఉండడానికి ప్రాబిలిటీ వాల్యూ ఎంత? 1. కాబట్టి ద ప్రాబబిలిటీ ఆఫ్ ఫైండింగ్ ద పార్టికల్ ఇన్ బిట్వీన్ x is equal to 0 and x is equal to a is always maximum. Probability maximum means that value should be equal to 1. So mathematically how to represent 0 to a mod psi square dx is equal to 1. What is this represents? The probability of finding the particle in between 0 to a is always equal to 1. This is the probability function. Mod psi square represents the probability of finding the particle. So probability particle ఎక్కడ ఉందమ్మా? 0 నుంచి a దగ్గర. That value should be equal to 1 maximum. Now integral 0 to a mod psi square can be written as a square sine square n pi x by a into dx is equal to 1. But according to definite integrals concept, integral 0 to a sine square n pi x by a into dx is equal to half of the upper limit. Upper limit antama a. So a by 2. It is equal to half of the upper limit. So this becomes a square into a by 2 is equal to 1, and from this a is equal to root 2 by a. Now this equation can be written as psi of x is equal to under root 2 by a sine n pi x sine n pi x by a. This is called the eigenfunction of a particle in a one-dimensional box. This is the eigenfunction and this is the eigenvalue. ఇది ఎగ్జాంపుల్ అడుగుతుంటాడమ్మా. So obtain the eigenvalue and eigenfunction of a particle in a one-dimensional box. This is the value of a. This is the eigenfunction. Eigenfunction. E-I-G-E-N. Eigenfunction of a particle in a one-dimensional box. This is eigenvalue of a particle in a one-dimensional box. So, thank you. నా ఛానల్ని సబ్స్క్రైబ్ చేసుకోండి.